Let's multiply some decimals. Our first problem is about Tess, who bought 3 pounds of jelly beans for Easter. The jelly beans cost $4.25 per pound. And we want to know how much did Tess spend on jelly beans. So obviously our expression is going to be 3 times 4.25. And what I'm going to do is I'm going to use common sense to help me multiply these decimals. Okay, so what I'm going to do is I'm going to start off by estimating. And the way that I'm going to estimate is I'm going to look at the decimal, which is 4.25, and I'm going to say, you know what? 4.25 is really close to 4. Or at least it's close enough to really help me with this problem. And so I am going to estimate that my problem is going to be close to 3 times 4, which hopefully we all know is 12. And I'm going to use that estimate at the end to place my decimal point. So I'm going to rewrite 4.25 times 3. And you'll notice something that might look strange to you. Because when we add and subtract decimals, we always are very careful to line up decimal points. But when we multiply, that's not the case. And there's a reason. So let's take a look at what we get when we multiply. After I get my estimate, I am just going to ignore the decimal point and multiply these two numbers as if they were whole numbers. So I know that 3 times 5 is 15, and 3 times 2 is 6, and 1 is 7, and 4 times 3 is 12. And so I'm looking at this and I'm saying, well, she definitely did not spend $1,275 on jelly beans. So I'm going to go back to my estimate and I'm going to ask myself the question, where can I place the decimal point so that it is the only place that makes my answer agree with my estimate? Because that's the only way, given a problem like this, that I can make sense of it. And math has to make sense. So I'm looking at my estimate and I'm going to say, gee, there's only one place to put that decimal point where it makes sense, and that's between the 2 and the 7, so that I can say that Tess spent $12.75 on jelly beans. Okay, so that's the way that I do it, especially in the context of a word problem. Now let's look at another problem. This one's not a word problem, but I'm going to do it the same way. I'm going to look at my numbers, and when I'm estimating to place a decimal point, I don't have to use the strict rules of estimation because I'm not rounding. When you round at the end of a problem, there are certain rules. When you estimate, the whole purpose of estimation is to make the problem easy, and so that your estimate is not that far off from your answer. So instead of rounding this up to 13, which is what I would do at the end of a problem, I'm going to what we call truncate it. I'm just cutting off the decimal, and my estimate is going to be 12 times 5, because that's easy for me to do. And an estimate above everything else needs to be easy. So I know that 12 times 5 is 60. And so my answer when I multiply should be somewhere around 60. So I'm going to take this and I'm going to rewrite it vertically. And again, you'll see I'm not lining up my decimal points because it's not important to do that. And so 6 times 3 is 18, and 6 times 2 is 12. and 1 is 13. 6 times 5 is 30, plus 1 is 31. Okay, hold the place. 2 times 3 is 6. 2 times 2 is 4. 2 times 5 is 10. Now I have to hold 2 places. And this is easy. 1 times 3 is 3. 1 times 2 is 2. And 1 times 5 is 5. So let's add this up. And we have 8. And 3 and 6 is 9. 3 plus 1 is 4, and 4 is 8. 3 plus 2 is 5. And 1 plus 5 is 6. Okay, well, that's certainly not the answer, 65,898. But look back at our estimate. Our estimate is 60. Where is the only place that you can put the decimal point so that your answer will match 60? And that is between the 5 and the 8. And so your answer is going to be 65.898, or 65 and 898 thousandths. Now, in order to check the placement of the decimal point, I don't really do this because for me, if it makes sense, then that's good. Okay, but some people do this. Some people sum up, okay, the number of decimal places to the right of the factor, the decimal point in the factors. So 5.23 has 2 decimal places, 12.6 has 1 decimal place, and so your answer should have 3 decimal places. In other words, 3 places to the right of the decimal point, and here we have 3 places to the right of the decimal point. Okay, let's do one more problem. Now, okay, when we work with small numbers, it's very, very hard to get an estimate. So that's when I defer to this counting the decimal places. Okay, so let's do this. Let's make it small so it all fits on the screen. 0.016 times 0.23. Again, you will see that I don't line up my decimal points because, again, my answer is going to not match up to the number of places to the right. It's going to be the sum of the places to the right in the factors. So let's ignore the decimal point. We're not going to estimate because it's really hard to estimate with such small numbers. We're just going to multiply as if those decimal points did not exist. So 3 times 6 is 18. And 3 times 1 is 3, and 1 is 4. Okay, hold the place with the 0. 2 times 6 is 12. And 2 times 1 is 2. And that would be 3. Okay, so now let's add this up. 8. And 4 plus 2 is 6. And 3. So now, what do? I have no estimate to compare it to, but I can use my trick that I did in the last problem, and I'm going to add the number of places to the right of the decimal point. This has 3 places. This has 2 places. And so my answer should have 5 places to the right of the decimal point. And so how am I going to do that? I'm going to start all the way at the end of the number, and I'm going to go 1, 2, 3, and my little thing is going to make a straight line, but I don't want a straight line. So I'm going to go 1, 2, 3, 4, 5. My decimal point goes here. Well, what am I going to do to hold those 2 decimal places? I'm going to have to put 2 zeros. Because again, I have to have 5 places. So these 2 numbers, 16 thousandths times 23 hundredths, is going to be equal to 0.00368. Okay, and that is how we multiply decimals.